This is frame structure, and calculate shear force diagram and bending moment diagram of this frame structure. Consider this as a C and D. A to D distance is 5 meter, B to D distance is 5 meter, and DC is also 5 meter. Now, first calculate reactions. Summation of forces in horizontal equal to 0. So first see this whole structure and see horizontal forces. This 5 kilonewton and this 10 kilonewton per meter, and this Ax, and this side forces are considered as positive and this side forces are considered as negative. So positive Ax, positive 5 minus 10 into 5 equal to 0. So this Ax equal to 5 minus 50, it is minus 45. That means this is 45 kilonewton. This Ax equal to 45. Unit is this kilonewton. Now calculate summation of forces in y direction equal to 0. Upward force positive and downward negative. So upward positive Ay plus By minus 10. These three forces comes Ay, By, 10 vertical forces. So positive Ay, positive By minus 10 equal to 0. Therefore Ay plus By equal to 10 kilonewton. So take moment at this A point and calculate this By. Why we take moment at A point and why we don't take moment at B point? Because if we take moment at this B point, then Ax, Ay, 5, 10, this and this 10, this total 5 forces comes. And if we take moment at this A point, then By 10, 10, 10, only 4 forces comes. So our calculation is simple. That's why take moment at A and consider clockwise movement as positive and anti-clockwise movement as negative. So this 5 into 2.5, you see this go like step by step, like 5, 10, like this. So positive 5 into 2.5, see this 10 is clockwise and 10 is at middle of this DC, that means this is also 2.5. So positive 10 into 2.5. See this 10 kilonewton per meter, that means it is anti-clockwise to that A. This is like this, anti-clockwise. So minus 10 into 5 into 5 by 2. So see 5, 10 and this By minus By is also anti-clockwise. So minus By into 5 equal to 0. So this By equal to positive 5 into 2.5, positive 10 into 2.5 minus 10 into 5 into 5 by 2 and minus By into 5 equal to 0. So this By is minus 17.5 kilonewton. If this By is minus or reaction comes minus, then our assume reactions are, see this and this assume reaction direction. This assume reaction directions are reverse if minus comes. So this By minus comes, that means this is like this, reverse side, reverse direction like this. This is correct. Now next step is to calculate shear force calculation and diagram. First consider this AD, then DC, and then CB. So this AD is A to D, it is 5 meter, and at a distance of 2.5 meter this is 5 kilometer. See this AY-AX reactions. AY is, put this By in this equation 1. So 10 plus 17.5, 27.5 is this AY. This AX is 45 kilonewton. Now this D point is fixed point and is 27.5 kilonewton upward. So due to this 27.5 kilonewton, equal and opposite reaction comes. So this is opposite sign and equal reaction 27.5 kilonewton. Now for your SFD BMD calculation, or to get judgment of this calculation, always see this beam like this horizontal, and remember first point is always at this first. Go like this for solving, go like this like this. So first A point comes, then D. So A point is always left hand side. So A, D. So this is 45 kilometer. This 27.5 axial load. This 5 kilometer. Total is 5 meter. Now SFD, this will. This is 45 kilonewton. See, like this. This is downward, so minus 45 kilonewton. Unit is kilonewton. Between this portion, no load. So see, no load. So here also 45 kilonewton. Due to this 5 kilonewton load at 2.5 meter distance, it drops down. So minus 50. Again, this portion no load. So no load, that means here is only line, no change in shears. This is like this, 45 kilonewton minus. Now draw shear bending moment diagram also here. This is with support, hinge support. So at hinge support 0 BMD. So here 0 BMD. So see, this is downward. Now calculate BMD at this point. So this is anti-clockwise. So minus 45 into 2.5. Minus 112.5 and minus 112.5. Unit is kilonewton meter. Now calculate here. Again minus 45 point. Total distance between 45 into that point is 10 and minus 5 into 2.5. Consider minus 45 into 5. This distance into 5 and minus 5 into 2.5. It is minus 237.5. Now DC. See, at this point D, this 27.5 kilonewton load downward. That means here it comes opposite, equal and opposite reaction. (27.5 kilonewton). And at point D, moment is minus 237.5. Moment consider as it is. Because this is generated moment, so draw shear this 27.5 kilonewton goes upward. In between this D to that 10 kilonewton per no load. So again horizontal line. So positive 27.5 minus 10, it is 17.5 kilonewton. So 27.5 kilonewton here, 17.5 kilonewton positive, and here 0. See, By is minus 17.5 kilonewton. So here consider this as a By. B and C and B. By downward arrow. $17.5 kilonewton and downward, that means minus. So equal and opposite is upward 17.5 kilonewton, and here C like this 17.5 kilonewton. This is upward, that means this is downward, equal and opposite. Now movement, this is D, this is C. Movement at D is 237.5 negative. This unit is kilonewton meter. At this point minus 237.5, and this is clockwise to that point, so positive 27.5 into 2.5, so it is minus 168.75. Now calculate at this point positive 27.5 into 5 minus 237.5 plus again minus 10 into 2.5. It is calculate here minus 237.5 plus 27.5 into 5 minus 10 into 2.5. It is minus 125 kilonewton. So that means here moment takes similar, so 125 anti-clockwise. So see, draw SFD here, shear force diagram for this CB beam. CB SFD, no SFD because no transverse load acting here. Now calculate BMD. But see, no transverse load, but see this total whole structure, this CB 10 kilonewton per meter load is act here. So we need to consider it. And see the structure like this. This first point is C, this is B, 10 kilonewton per meter, and this CB is 5 meter, length 5 meters. this is this reaction, this is anti-clockwise, this is this reaction. So in that point C at point C there is this AX 40 kilonewton, so it is 45 kilonewton. Here 27.5 kilonewton, 17.5 kilonewton. See, this is roller support at point B. So at roller, shear is always 0. But see this, calculate shear here at this point. Minus 10 into 5. It is minus 50. And when we take shear from right to left, then change sign. That means here it is 50. 50 kilonewton positive. And at B it is 0. And this is UDL, that means inclined line. So this is positive. Now calculate bending moment diagram. 237.5. This is 237.5 kilonewton. Anti-clockwise, so it is like this, minus 237.5 kilonewton meter. This is kilonewton. Now calculate at middle of this point. That means from right calculate it. 10 into 5 into 5 by 2 is 125, and change sign, minus 125, so minus 125. See here, this minus 45 minus 5 is 50. Here 50. See, this 45 plus 5 acts on this, and here 45 plus 5, 50 kilonewton, equal and opposite reaction generates here. Shear generated. So this 50 will be like this, right? B it is like this. It is 50 kilonewton here, and here also it is 50 kilonewton. So as per this, here 50 kilonewton generates. So that's why this 50 comes. And this is upward C. That's why positive 50. And at this location, positive 50, midpoint at positive 50 minus 10 into 5, 10 into 2.5. mid is 2.5. It is 25. So here at mid it is 25 kilonewton. This is manually calculated shear force and bending moment. Now draw shape. This is shear force diagram. And this is bending moment diagram. First is 4550 to 37.5. This is minus 45. This is also minus 112.5 to 37.5. Unit is kilonewton meter. And SFD is kilonewton. This is 27.5, 17.5. This is 50. Positive draw away from structure. Negative inside structure. This is 237.5, 168.75. $168.75. And $125. This is negative. It's 50.25, 237.5, 125. See here at this point minus 125. Minus here why we write 237.5. Here we need to write 125. So positive 50 into 5 minus 10 into 5 into 5 by 2 minus 125. See here 125 movement comes, and at mid, see at mid 50 into 2.5 minus 125 minus 10 into 2.5, so minus 25. Minus 31.25, because see this anti-clockwise is minus 125, this is 50 into 2.5 is minus 10 into 2.5 into 2.5 by 2 is minus 31.25. Minus, this is also minus. So now see this in StatPro software. New unit is metric, create. We will do modeling node wise. There is one more option, grid wise also. This is beam grid option here. See, we will do grid wise also. Here snap node, click on snap beam. This is 0 to our total height of this is 5. Okay. 5 here, 5 to 5, again 5 to 5. Now close. To see nodes are generated here. Go to properties, define some property. For errorless calculation, we need to provide this property. We are not interested to calculate BMD for that tail load, but in StatPro software, there is necessity to define material and section properties. Now support. C. A is pin and B is roller. So create. This is pin. Use cursor to assign. This is pin. and fixed but this is roller. In roller only vertical FY reaction comes, all others are releases. That means all others are free to move, translate or rotate. Now loading 10 kilonewton. Here load case details. Add load is live load, load case 1, close, load case 1, add member load, concentrated force 10 kilonewton downward y direction, that's why minus, and at a distance of 2.5 meters, center of that beam. Select 2.5. Use cursor to assign. So assign to selected beam. Assign. Yes. So see this green color. This 5 kilonewton is also at 2.5 meter. So again add. Click on load case 1. Add. Go to member load. Concentrated force in GX direction 5 kilonewton. And at a distance of 2.5 meter to that beam. So add, close, click on that load, this beam, and assign to selected beam, assign, yes. Now see, if I click on this 10 kilonewton load, then this load is green color. If I take on 5 kilonewton load, then this load is green color. Now UDL 10 kilonewton per meter on that portion. Again click on load case 1, again click on add, go to member load and click on concentrated force, click on uniform force, uniformly distributed force 10 kilonewton. Force is 10 kilonewton in GX direction, but it is away from GX direction, to minus sign. This is select load, select, assign to selected beam, assign, yes. It is not seen, so right click, labels, scale, click on apply immediately, click on distributed force and reduce the scale. See it may see reduce. See, this force is correctly applied. Now go to analysis, define command, all. If you don't do this define command, then there is error comes instead, bro. So run analysis, save. So go to post processing, done. See deflection. Because he from this side more load, 10 kilonewton meter load acts and this is roller support. Now shear. See 4550 negative, 4550 negative, 27.5 17.5 positive, 27.5 17.5 positive, 50. So exactly match SFD shape and our manually calculated shape and magnitude exactly match. But I told you in our previous lectures also that BMD shape is not matched with software and manually calculated. Because why? Because of sign conventions. Our manually calculated positive, that means TAD is negative. Our manually calculated negative, that means TAD is positive. That's why this STAD consider hogging moment as positive, and we consider in our manual calculations hogging moment as negative. That's why this all happens. So see this all bending moment diagram in software seen outward side. See what magnitude is similar. See 237.5. See 237.5 here. Here also 237.5. Here 125. Here 125. And here at a distance of 1.5 meter it is 37.5. The distance of 2.5. See 37.25. See here 37.25. At a distance of 2.5 here 168.75. So 168.75. 112.5 here. So we'll check. 112.5 here. So that way our SFD and BMD values matches each other.